All right. So we're going to talk about arrays, and I'm going to show you, hopefully today, how arrays and pointers are connected. Let me return. All right, so I know that you know Python. And in Python, we don't call those arrays, we call them lists, even though it wouldn't be the end of the world if you call them arrays. But this is not really the terminology that they use. They use lists, and you do something that looks like this: my list equals to, and you give it numbers like that. So that's kind of what you do in Python. Or maybe you can say my list of floats is going to be 1.5, 1.9, 9.4. You can also do that. And of course, you can create a list of strings, and you can actually create a list that contains different data types. You can do that in Python. In C, it's a little different. In C, when you create an array, it's not called a list. In C, it's called an array. When you create an array, you need to define the data type. This is actually necessary. So is it going to be an array of integers or an array of floats, or is it an array of shorts or an array of pointers if you want? We're going to, of course, keep it simple, and we're going to say, let's do an array of integers. So I would say int my array. And in addition to kind of specifying the data type, you have to also specify the size. And you do that by having square brackets on the same line that you use to create that array or declare that array, and you would give it some size. And this size here, 10, is going to be the size of the elements of my array. So you can do that. That's perfectly fine. And then you can give it values. Now, the way we access those elements is going to be very similar to how we do it in Python. So we can say my array is 0. So that would be the first element equals to something, say 200. Then my array 1 is equal to 300. My array 2 is equal to 150. Just these are random values. My array 3 is equal to 20. And my array 4 is equal to, say, 50. And let me make this 5. So that's code that works. It's not going to do anything in the sense that it's not going to print anything. Of course, it will create an array and it will assign values to the array elements, but it's not going to print anything. Of course, you can print, say, for example, the value of the first element is $d\n. And of course, I use $d because it's an array of integers. And here I can say my array is 0. So this is identical to Python. That's how you change the element, by saying my array, index equals to something. And this is how you access the elements, my array, and then you give it an index. And of course, you can say print if the value of the second element is $d\n, my array 1. And you can hit play, and you will see that it's going to print the right values. 200, 300. Now, of course, you can have a loop that populates the values. You can say for L. Right now I'm writing Python. Let me do for. I spend most of my day, well, most of my coding is Python. So I'm able to kind of switch between Python and C, but every once in a while I make mistakes. So I'm going to say int control variable equals, let me just do that, and let's say control variable equals to 0. Control variable is less than 5. control variable plus plus. Let me do this. Yeah, that's all good. And here I'm going to say my array control variable is equal to maybe control variable multiplied by 200. And let me actually get rid of all of that. Let me comment all of that. So here I'm creating the array, and that will declare space. And here in this loop, I'm assigning values to those elements. So for the first element, which has index 0, the value is going to be 0 multiplied by 200. So it'll be 0. And then we have 1 multiplied by 200, that'll be 200. So that's what we're going to see if I hit play. So you can see 0 and 200. All right. So when you do this, when you create an array, declare an array, a space gets allocated. Okay. So in this case, can someone tell me how many bytes that's going to be? Think about that for a minute. How many bytes do you think that's going to be? 20. That's good. You're exactly right. It's going to be 20. And 20 is going to look, they're going to be contiguous. It's going to look like that. And I'm going to change the color of this to green. So the first 4 bytes are going to be kind of, this is the space for the first element. And of course, these 4 bytes will be same thing, except it's the second element. And we can merge those. You get the idea. This one's going to be third, and then the fourth is going to be here, and the fifth is going to be here. Let me add a few. Well, I don't want to add a few here because that will make these 2 numbers incorrect. Let me add a few above this. Let me remove. Okay, that looks good. And you know what? I'm going to just merge this and say fourth. And I'm going to say fifth. Do you have any questions about any of that before we talk about something that you don't know? So what I'm going to talk about is something new. But before I do that, do you have any questions about this? Kind of this, creating an array, which will allocate space. And then here we're looping through the array and we're giving each element a value. This one's going to be 0, 100, 200, 300, 400. And of course, I can print values by using this notation that we're very familiar with. All right. So let's talk about something new. I mean, it's going to be, of course, about this topic, but it'll be probably new for all of you because it involves pointers. Now, when you create or declare an array, it's true that this space will be allocated. So what's happening is true. But there's another thing that happens that I bet you didn't expect. A pointer gets created. A pointer that points to the first byte of your array. Seems like like a scary movie here. Pointer gets created. All right, so let me kind of organize things a little bit. When you create or declare an array, one space gets allocated. And of course, that would be, in this case, as you guessed, 20 bytes. And in addition to that, a pointer gets created, and that pointer points to the first byte of your array. So that pointer is going to be 8 bytes as usual. Let me make this one. Let me make it, I can make it wide, that's okay. And this pointer, the value of this pointer is going to be the address of this byte. What do you think of that? I'm going to pause here. I want you to think about that a little bit and think about this while I write the addresses here. We have 0 here. I don't want to write this one here, but because that'll mean I need to change this one. But we have 8 here and we have 16 here. Again, I cannot write the address here, but it'll be 16 plus 8 and plus 8 here, which would be essentially 16 plus 16. That would be 32. And here there would be 40, and here there would be 48. Let me pause here and see if you have any questions. So do we agree on those numbering? 0, 8, 16, 32, 48, and here we have 56, which is, of course, 48 plus 8. Every row is going to be an 8. Which means that the value of this one is 56. Okay. So I hope all of that made sense. Right now we're going to do some sort of, some examples that will essentially prove to us that this is kind of true. Or rather, can at least demonstrate to us that this is true. Now, this pointer that gets allocated actually has this name. It has my array. So the name of the array is really a pointer. When you create an array, essentially you're creating a pointer. You're doing more than that because you're allocating space, and sometimes you're putting values. Even on this line, I can show you later how to put values in the array on the same line. So you are doing more things than just creating a pointer, but one of the things is really to create a pointer using the same name. So a pointer gets created, and that pointer points to the first byte of your array. So let's kind of do some basic stuff. And I'm going to actually ask you questions. And these questions are not going to be necessarily the easiest questions, but I would like you to try to answer them. And let me maximize this. I mean, that'll be a fun, kind of challenging exercise. So I'm going to say print if the, let's start with something here. Okay, before we do that, let me tell you one more thing because I don't want to make it too challenging. A pointer gets created, a pointer of type, a pointer that points to an int. Let me do that. Pointer that points to an int. So it's a type pointer that points to an int. gets created that points, let me do that, to the first byte of your array. Okay. Yeah. Okay, there's a question here going back to this. Why is this 56? Well, this one is 0, and this one's 8. Are we good with this one? So 0, 8, is that, are we in agreement that there's 0, 8 here? Because this one is going to be the base. Okay, so 0, 8, 16, and 16 plus 8, 24. Then 24 plus 8, 32. 32 plus 8, 40. 40 plus 8, 48. 48 plus 8, 56. But let me think about your question. 76. Do you want to rephrase your question? Maybe I'm missing something. The first byte of the array. This is the first byte of the array. Yeah, the address. So the address of the array is the address of the first byte, and the pointer points to the first byte. So the address of anything is the address of the first byte of that thing. So when someone says, what is the address of the array? It's going to be the address of the first byte. Let me read your question. Why doesn't the address after the array account for all the lines that the array fills, as well as the following empty line? So the reason why we stopped here is because we defined five elements. I think I'm not quite sure, actually, I understand your question. But the reason why of course, we could have started anywhere, right? I randomly decided to start here. We could have started, of course, we do have some things here, would have been 80. I would have thought the value of the pointer would have been 80. So 80 would be, of course, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 80. Yeah, you're saying so the address of this byte is 80. You're saying you think that this should be 80 or 88. 88 is here. Well, I mean, if the pointer is pointing at itself, then it's kind of useless. I mean, a pointer pointing at itself is not really giving us any information, any additional information, because we can get the address of the pointer. I mean, if we get the address of the pointer, okay, do you see what you did wrong? Okay, all right, okay. All right, I'm glad you were able to figure out what the mistake was. Okay, so this is 56, which is here. And if you have other questions, again, feel free to ask them. Let's go back here. Okay, so quickly to kind of continue what I was saying, when you do this, a space gets allocated. A pointer that points to an int is going to point to the first byte of the array, or it's going to contain the address of the first byte. Now, my question to you is, if I do the value is %, d \n, comma, and I'm going to dereference my array. Again, this is not necessarily the easiest question, but I want you to think about it. So what I'm doing here is I'm dereferencing my array, which is really a pointer that points to something. What do you think that's going to print? The value is what? Think about that. I'll give you a minute. The address of the array, 56. No, not quite. First of all, let me go back to kind of the first answer, which is the address of the array. If I say the value is, it's going to be really the address is %, p \n my array. So that is going to give me the address of the first byte of the array, which is the address of the array. Why? Because my array is a pointer. This is my array. The value of my array is going to be the address of this. So if I print the value of my array, it's going to be the address of the array, which is the address of the first byte of the array. So this one is not going to print the address. So let me get rid of that. So Anthony is saying it's going to print the first element. This is actually correct. It's going to print the first element. Why is that? Let's think about it together. This is the pointer, which contains the address of the first byte. Remember, when you dereference a pointer, you're getting the thing, the value of the thing that this pointer is pointing at. In other words, you're getting the value of the thing that lives at this address, 56. Now, 56 is here. The thing that lives at 56 is the first element. And this is actually very important. And it's actually, excuse me, it's related to what I've added here. It's a pointer that points to an int. And this was very important for you to know, because when we get the thing that lives at 56, going back to what we talked about earlier, I need to know how big that thing is. Because when I say get me the thing, I need to know how many bytes I would have to get. And because a pointer that points to an int gets created, the thing is going to be an integer. The thing is going to be 4 bytes long. And when you dereference my array, again, you're saying get me the thing that lives at this address, and that would be the value of the first element. So that's what Anthony said. That's correct. Of course, we know what the value of the first element is. It's going to be 0, because when I populated the values, that's what I did. So maybe let me change this one and make it, because 0 is not a very good number. Let me make it more distinguishable. Let me say plus 200. So if I say plus 200, there's going to be 200 here, 201, 202, 203, 204. So let me hit play, and that's going to be 200. It should tell me 200. Or maybe, let me say plus 1 here and multiply by 200. So if you think about that for a minute, just before we proceed, just make sure we know what's going to happen here. When my control variable is going to be 0, essentially the first element in my array is going to be 0 plus 1, which is 1 multiplied by 200. So you're going to see 200 here. And then you're going to see 2 multiplied by 200. So you're going to see 400 here. Then you're going to see 3 multiplied by 200. So you're going to see 600 here. So that's what's what's going to happen. And here, if I dereference my array, which is a pointer that points to the first byte of my array, it's going to give me, in this case, 200. All right, do you have any questions? Okay. Let's do another example that is kind of similar. So I'm going to here say return. And I'm going to create an array of characters. I can say int my letters. And I'm going to say, let's say 5. Actually, let's do 5. That's okay. And then I'm going to say my letter 0 equals to h. So right now I'm not going to use a loop. I'm just going to give some values. My letter 1 equals to e. My letter 2 is equals to l. My letter 3, can you guess what I'm going to write? Hello. My letter 4. Okay. Oops, char. Yeah, I did say int. Thank you, Anthony. It's supposed to be char. And I'm gonna create another one because I'm gonna erase everything here. And I'm gonna unmerge and unmerge all of those. Unmerge all of those. Oh, I said merge by mistake. Let me unmerge. Okay, that's good. Let me make all of that no fill. And let me actually make all of that no fill. Let me unmerge. Let me make it all. Okay. So how many bytes is that? Can someone tell me? How many bytes is that going to be, this array? 5, exactly. Very easy. Hopefully 1, 2, 3, 4, 5. I'm going to change the color of it. And what's going to happen here is that we're going to have the ASCII code of those letters. Now, just to make it simple, I'm not going to write the ASCII code. I'm going to write the letter. But just imagine that in the actual memory, you're going to have the ASCII code of this, the ASCII code of this, ASCII code of this, ASCII code of this, ASCII code of this. That's how it's going to be stored. Now, in addition to that, let me make this white, the text. It'll be easier to read. In addition to that, we're going to have a pointer. We don't want to forget that. And this pointer is going to point to where? Is going to point to the first byte of the array, which is here. So this pointer, which I'm going to right now merge, is going to contain the value. So here we have 0, we have 8, we have 16. So it's going to contain the value 16. Now, if I want to print the first character, I can say print if the first character is %c\n. Of course, I can do this, but I suspect that you know that that's not what I'm going to do. I'm going to use the pointer, which is my letters, and I'm going to dereference it. And let me hit play, make sure that I got the correct answer, H. Okay, that's perfect. So I'm going to ask you right now a tough question. And I don't expect you to be able to give me the perfect answer, but if you can give me an answer that's in the right direction, I think I'll be very happy. Can I print this letter, E, using my letters pointer? Now, of course, let me just be clear here. Of course, I can print the second character is %C\n my letters 1. I can do that. That's going to print E. That's going to print the second character here. But my question to you, just to make sure that you see I have E. My question to you is, can I print the second letter using this pointer as opposed to using kind of this square bracket notation? And I'll give you some time to think about it. So Grace provided a very, very good answer, which is, how about we do my letter, kind of star my letter +1. Now, I'm going to actually do that. It's not right. This is incorrect. But the reason why I'm going to do it, because I think the answer is going to give you a hint on what went wrong, on what Grace did wrong. So this is not quite right. It's very good. It's a very good answer. I like it a lot. But it's not going to be the correct answer. And I think the answer that you're going to see is going to give you a very good clue on what you need to do. Let me hit play. It said the second character is I. That's odd. I mean, it's not odd to me. I did expect that, but I'm just... Okay, so Katie's saying this is the ASCII code +1. The ASCII code of which? The ASCII code of what? Exactly. That's the ASCII code of H uppercase +1. So this is good. So what we did wrong here is that we got the ASCII code, which is really we got the letter, excuse me, and then we added 1 to it. So we dereferenced before adding. What Grace wanted to do is to actually go to here, then dereference. So you want to take the point. So right now the pointer 16 is pointing to here. The value 16 is pointing to here. And I'm going to assume, and I'm sure that this assumption is correct, that what Grace wanted to do is wanted to go to the next one. So wanted to go to 17 and then dereference that, which would give us E. However, when you dereference this had a priority. So this actually executed first. And then we added 1 to it. And we really didn't want this to execute first. We wanted this to execute first. Is that correct? Is that what the intention was? Yeah. So that's good. So Anthony is saying simple. There's this thing called parentheses that I know that we can use like that. So instead of kind of dereferencing my letters, we can just say my letters, which is 16. We can add 1 to it, and we hope that it'll get to here. And then I can dereference it, and I think it's going to give me an E. Let's try. Let's cross our fingers. All right, perfect. That's the correct answer. That is the answer that we wanted. So we started with the pointer, which points to the first byte. And we said, let's add 1 to it so that it can go to the next byte. And then let's dereference that. So when you add 1 to this, of course, you end up with 17. You dereference 17, that's going to get you the value that lives at address 17. And we know we're going to get a single byte because this array is of type character, which means that the pointer is going to be of type pointer that points to a character. So when you dereference that type of a pointer, you always end up with 1 byte because the size of a character is 1 byte. Now, of course, if you want to get to the third character, it's easy. All that you have to do is add another number. All right. Do you have any questions about this? We still have 15 minutes, and I need to talk about something important. But of course, if you have questions, that's okay. I will hear them out. Your questions are more important. Okay. No questions, it seems. Let me kind of do an example here. And let me say int. So I'm going to go back to int. And let me say my numbers, my nums, let's say 5. And I'm going to say my nums 0 equals 2. 17, my nums 1 equals 2. 19 or 29, my nums 2 is equal to, some random value here. My nums 3 is equal to 100. And my nums 4 is equal to 19. Let me kind of do that really quickly here. I think it'll help to visualize that, even though I think you get the idea, but still, I'm going to do it here. Let me merge this one. And 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 let me make those all the same color. Make it darker here. And let me make this white. And you know what? I'm just going to go 4 elements. So I'm going to get rid of that, and I'm going to say 4. So right now what we have here, of course, we have 17. Then we have 29, 98, so 29, 98, and then 100. Now this font, first of all, let me do this. Okay, that's good. Change. Yeah. So let me do something and let me ask you a question. The value of, I'm going to do dot, 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 because I don't want to give you a hint on what the answer is going to be. %, d\n, dereferencing my num. Who can answer this question? This shouldn't be difficult. We've done that. So I'm dereferencing my nums. What would that be? 17, that's great. And this is correct. And that would be, of course, here. Now we can keep that. We can put an address here. That's 16. All right. So can someone tell me how to actually, you know what? I'm going to actually go back to 5. Bear with me here. You're going to see why I'm doing this. You're going to think that it's not useful, but it's actually going to be useful because I want to make sure that when you see something wrong, I want to make sure that what you see is going to give you maybe a clue on what's wrong. And this is, as you will see in a few seconds or a few minutes, you'll see why this is kind of important to give you a clue. Okay, so my question to you right now, how can I print the value of the second element using my nums? Of course, I don't want to use the square brackets. I still want to use the dereferencing notation. So kind of similar to what we did here, maybe. Can someone tell me how to, I mean, close enough, right? I mean, not necessarily identical to what we have here, but maybe something similar to what we have here. So I want to print if the value of the second element in my array is something, %d\n. And here, okay. So let me see what some answers are. Okay, so Anthony's saying +1 multiplied by that. Okay. So this is not really the answer that I was expecting. Let me paste Katie's answer and let's kind of discuss it for a second. Okay, so let's all talk about this, and feel free to unmute yourself if you feel that it'll be easier to talk as opposed to chat. Feel free to do that. So what is my nums? My nums is 16, which is here. Let's give me a thumbs up or tell me that this makes sense. So 16 is pointing to here. Okay, so 16 is pointing to here. And where do we want to go? I mean, what is the goal? Where do we want to go? We'd like to be here. Because if we're here, we can dereference that address and that'll get us 4 bytes, which is really what contains 28. So we're here. We'd like to be here. Is that clear? If you want to get the second element, you need to take this address 16 and you need to make it 20. So anybody wants to change this answer? Do you feel that this is the correct answer, or do you feel that you want to change it? Who thinks this is the correct answer? Give me a thumbs up. Okay, who thinks this is the wrong answer? Give me thumbs up. I should have said thumbs down, but okay, I can see that. Give me thumbs up or thumbs down if you think this is wrong. Okay. So you are right that it makes kind of more sense to see this. You're right about this because my nums is going to be 16. And it kind of makes sense to add 4 so that you can go to the next integer and get that one. So I do agree with you that this is a very good guess because, we don't want to end up here. I mean, you don't want to end up in the middle of an integer because then you're going to take some bits from this integer and some bits from this integer. You're going to end up with an odd number, maybe. So we don't like to end up here. We want to be here. And because 16 is here, it seems as if it makes the most sense if we add 4 to it. And this is all fine. Now, let's see what's going to happen. And based on the output, hopefully you're going to realize what happened and maybe you're going to change your answer. So I'm going to stick to this. So I'm going to say, I'm going to copy all of that and I'm going to do this. And let me hit play, and then maybe you can think about what happened when you see the output. Okay, so it's saying the value of the second element in my array is 78. Well, this looks odd because the value of the second element is 29. However, it printed 78. What is 78? 78 is this element, which is really here. So this should be a little confusing, right? We were here and we added 4 and we ended up here. So Katie, you're right. The correct answer actually was the first answer that you proposed, even though I'm not quite sure if you kind of intentionally proposed the correct answer because you knew what was happening or because you kind of mimicked what was happening here without kind of giving it, enough thoughts. Either way, I can assume that you gave me the correct answer because you knew. But let's make sure that we can explain it and make sure that we can we understand what's happened, and then I'll be happy to answer any questions. But Katie, to answer your question, that is correct. +1 is the correct answer. And the reason why this is the case, I'm going to write it here in uppercase, not because, again, I'm yelling, but because it's very important. There is something called pointer arithmetic. Pointer arithmetic is when you add an integer to a pointer. And this is different than integer arithmetic. So integer arithmetic is when you add an integer to an integer. Pointer arithmetic is when you add an integer to a pointer. And pointer arithmetic can be very confusing at the beginning because it doesn't seem that it's adding up. However, the reason why pointer arithmetic behaves like this is because when you add 1, pointers are so smart, or rather C is so smart, it knows that you don't want to be here. It makes no sense for you to be here. There's no reason for you to be here in the middle of an integer. So when C, the compiler C, looks at this and it says you want to add 1, it'll say, oh, clearly you want to go to the next integer. So it's going to add 4. It will actually add 4. It's not going to add 1. And let's hit play and make sure that it's giving us the correct answer. You can see it's 29, which is the correct answer. And you know what I'm going to do in addition to that? I'm going to print the address to show you that adding 1 means adding 4. So I want to show you that. So I'm going to say printf, the address of the first element is %p \n, and I can say my nums. And then here I can say printf the address of the second element is %p \n, and here I'm gonna do my nums +1. So I'm just gonna simply add 1, but you will see that this one is gonna actually add 4. It's gonna be in hexadecimal, but it's not gonna be very difficult. This is the address of the first element, and when you add 4 to it, you end up here. So this is very important. Even though I'm adding 1, I ended up adding 4 because this is a pointer that points to an integer, and the size of an integer is 4. So when you add 1, the C compiler is going to say, oh, you want to add 4 because you certainly do not want to end up here, and you certainly do not want to end up here, certainly don't want to end up here. Adding 1 is going to go to the next integer. Give me thumbs up or thumbs down if that makes sense or if it doesn't. Okay, perfect. Now, of course, if you print the address of this and the address of this, you will see that this is +1 because this is a character. And I encourage you to do that. I encourage you to actually write this code, try to print the value of my letters, which is really the address of the array or the address of the first element, same thing. And then try to print my letters +1, and that will be +1. So +1 here will mean +1 because the size of a character is 1 byte. However, +1 here is going to mean +4 because the size of an integer is 4 bytes. So this is called pointer arithmetic. And it's very important that you kind of make sure that you understand it. But I have a feeling that you fully understand it based on your answers and your questions and your reactions. So I'm really happy that we were able to finish this one on time, because tomorrow we can do more. We can do a quick review, of course, of this, but we can do the last topic of C, and we'll be done with the C programming. All right, any questions before we end the session? So that's a good question. Let me stop the recording and let's chat about this thing.